The new section is entitled Variation of Parameters. We've done this earlier, but now we're going to do it for second order differential equations. So the goal basically is to get a particular solution to be some function of x times one homogeneous solution, or plus another function of x times another homogeneous solution, or a solution to a homogeneous equation. So the first thing we're going to do given a differential equation is we want to find these two functions. For example, if you have y double prime plus y is equal to tangent x, and we're asked to solve this. Well, first we want to find our solutions to the corresponding homogeneous equation. The auxiliary equation will be this. So this must be -1 because that's the only number you can add to 1 to get 0. So m is going to be plus or minus I. 1i. In fact, 0 plus or minus 1i. So the homogeneous solution will be e to the 0x, e to the alpha x, and b is 1, times c1 cosine of 1x plus c2 times the sine of 1x. And this 1 in front we don't need. So that is the homogeneous solution. Y homogeneous is c1 cosine x plus c2 sine x. In fact, that's the y1 and the y2 that I'm looking for. That's the y1 and the y2. And I was mistaken when I said that they were solutions to the homogeneous equation. Now first, I erased the equation, so let's put it back. Now, u1 prime is always going to be the division of two determinants. The bottom determinant is always going to be y1 and then y1 prime and y2 and y2 prime. For the record, when it comes to u2 prime, the bottom is going to be y1, y2, y1 prime, y2 prime, the determinant of that. The numerator is going to be the same, except when you're when you're dealing with u1, the first column will be different than that determinant. That is, the second will be the same. y2, y2 prime. When you're solving for u sub 2 prime, the second column will be different. The first column won't change. That is, it won't change from what's beneath it. That is, it'll be y1, y1 prime, just like it was in that first column. So what is the missing column going to be? It's always going to be, first of all, I should say, we should have a 1 here, and we do. If we had a 3, we should divide everything by 3. What goes in that for that missing column is 0, tan x. 0 and tan x. 0, and tan x. So in general, if we call this function over here g of x, it's really 0 g of x, always. So when you're dealing with u sub 2, the second column becomes 0 g of x. When you're dealing with u sub 1, the first column becomes 0 g of x. Okay. So let's do the bottom determinant. y1, y2. Remember, y1, y2. And underneath that, I put the derivatives. And since I'm solving u1 becomes 0 tan x. Sorry, first column becomes 0 tan x. Second column is just like it is below. It's just like that. And then you multiply. You multiply that product, which is 0, minus that product, sin x times tan x. In the bottom, you have 1. You have cosine squared x minus negative sine squared x. So that becomes plus. And you should recognize that bottom is 1. So that means this bottom is 1. So you have y prime. This is y. This is y prime. That's 0. And that's g of x. In the bottom you have 1. That product, cosine x times tan x. Well, tan x is sine x over cosine x. Cosine x is cancel, and you just get sine x. Minus 0. Sine x take away 0 is sine x. Divided by 1, it's sine x. So we have u1 prime and u2 prime. To save a little space, or to get a little space, I'm just going to move over the answer. u1 prime is that, because anything divided by 1 is to anything. It's negative sine x times tan x. And u sub 2 is sine x. U sub 2 prime, excuse me. I'm not proving why any or all of this works. Just showing you the steps. If you have u prime and you take the integral, you'll just get u. Take the integral to the left side, have to take the integral to the right side. The integral of sine of x is negative cosine x. Okay. Now over here, we have negative sine x times tangent x, which is sine x over cosine x. Now, I don't know the integral of this. That's why I'm trying to work with this. And I don't even know the integral of this. But it's negative sine squared x over cosine x. I do not know the integral. So I start thinking. I know that sine squared x plus cosine squared x is 1. If I interchange these two, the cosine squared stays, and the 1 comes over as minus 1, and the sine squared goes over as negative sine squared. And the reason I wanted negative sine squared is that's exactly what I have on top. Negative sine squared is cosine squared x take away 1 over cosine x. The reason I like this is now I can do some division. For example, that division is nothing more than cosine x. minus, and that division is 1 over cosine x, which is secant x. Now this I can integrate. u1 prime is equal to that. I integrate both sides with respect to dx. So I get u is equal to the integral of cosine x is sine x minus the integral of secant x, you should remember, is ln plus secant x plus tangent x. And that's u1. Okay. So I have u1 and I have u2. And right up here, I'm going to write down y sub p. Y sub p is equal to u1, which is this mess, sine of x, minus the natural log of secant x plus the tangent x times y1, which is cosine x. There's it right there. Plus u sub 2, which is negative cosine x. I can put minus cosine x times y sub 2, which is sine x. That is y sub p. Now once you have y sub p, getting the general solution is simple, assuming you also have y homogeneous, which we always find first. So y general is going to be yp sine of x minus ln of the secant x plus tangent x, all of that times cosine x minus cosine x sine x. If you say, hey, he just copied all of this, you are absolutely right. Plus the homogeneous, which is in this box up here. C1 cosine x plus C2 sine x. Problem's done. Once you catch on with the Kramer's rule technique, these are pretty straightforward problems. Y prime minus 9y. Let's say that's 9x over e to the 3x. Now, you must make sure you have a 1 in front. And we do. So everything's good. If it weren't, you would divide by what was in front. So we have y double prime minus 9y is 0. That is m squared minus 9 is 0. So of course that's 9. 9 minus 9 is 0. So m squared is 9, and m is plus or minus 3. So y homogeneous is c1 e to the plus 3x plus c2 e to the negative 3x. And that's our y1, and that's our y2. So not only did we find the homogeneous equation, but we learned what y1 and y2 are. y1, y sub 2. Okay. And I just like to write this down. yp is u1 y1 plus u2 y2. I have y1 and y2, I just need to find u1 and u2. Well, u1 prime is, well, on the bottom you have y1, which is e to the 3x, and y2, which is e to the negative 3x, and underneath that you have their derivatives. And in the numerator, it's going to be similar, except one column will be 0, 9x over 3x. Sorry, 9x over e to the 3x. And that's going to be column 1 that gets that. 0, 9x over e to the 3x. The second column is just like the second column in the bottom. E to the negative 3x, negative 3e to the negative 3x. You multiply those two, you get 0. Minus, you multiply those two, you get 9x over e to the 6x. Make sure you agree with that. On the bottom, you have negative 3 e to the negative 3x. Sorry, negative 3e to the 0. Because when you multiply these two, you add the exponents. If you have this negative 3 in front, you get negative 3 times 1, because that's 1, which is negative 3. Which is important to know because we're going to use this for the bottom. So this product is negative 3. Minus, now that product is positive 3. So again, it's minus 3. That product is 3. Only difference is that's plus. So you have plus 3. But you have to take it away. It's always this product, take away this product. So I'm going to take away this product, which happens to be 3. So the bottom's negative 6. Negative over the negative will be positive. 9 over 6, divide the top by 3 and the bottom by 3. So you get 3 over 2. That x stays on top. The e to the 6x comes in the bottom. So that is what u prime is. Okay. And to find u1, we're going to have to integrate u prime. So let's find u2 first. u2 prime, well, I know the bottom is this determinant, which is negative 6. And the top, well, the first column has y1 and then y1 prime. And the second column has the 0, 9x over e to the 3x. And have that product, which is just 9x. Because the e to the 3x's will cancel. Minus that product. Well, one of the things we're multiplying by is 0. So it's 0 with negative 6. Divide the top by 3, divide the bottom by 3, and it's negative. That is what u prime equals. You integrate that, and then u2 would be, that's going to be that constant, negative 3 over 2 times integral of x, which is x squared over 2. U sub 2 is going to be negative 3/4 x squared. So we have u sub 2. We need to find u sub 1. U sub 1 prime is that. U sub 1 prime is 3 over 2 x over e to the 6x. So I want to integrate. So u1 is going to be the integral of this. Of course, can factor out the 3 over 2. So we have x. Now I'm going to bring this to the top. E to the negative 6x dx. Now, one can do this by parts, and it'll take a while, or you can do what we call tic-tac-toe. Derivatives, integrals. We have a product here. if one of those factors, I can take the derivative of enough times to get 0, to annihilate it, but to get to 0. And I can integrate the other term just as many times as I took their derivative to get this to be 0. This is the way to do it. Right, x, e to the negative 6x. Take the derivative of x, you get 1. Take the derivative of 1, you get 0. Remember, the integral of e to any integer, any constant times x dx is just e to the kx, and then you divide by k. So our k is 6. When I integrate that, I'm going to get e to the negative 6x over negative 6. And when I integrate it again, I get e to the negative 6x over, and multiply that by negative 6 again, 36. And the integral is now we're ready to read off the integral. So it's going to be 3 over 2 times this product minus that product. But I hope it's clear that both of those products is going to have an e to the negative 6 factor. So this product is going to be negative x over 6 times e to the negative 6 minus this product, which will just be 1 over 36 times the e to the negative 6x in front. So we have u1. I'm going to write u2 up there. U sub 2 was negative 3/4 x squared. Negative 3/4 x squared. Going to write down what y1 equals. I'm going to write down what y2 equals. y1 is e to the 3x, and then e to the negative 3x. Now we are in a position to write down what yp equals. Remember that yp was equal to u1 times y1 plus u2 times y2. So now it's simple. u1 is 3 over 3x over 2e to the 6x times y1, which is e to the 3x, plus u2, which is 3/2 times e to the negative 6x times negative x over 6 minus 1 over 36. In fact, I'm going to factor out that minus sign. I'm going to factor it out. So now these are both pluses. So that's plus u2, and now I multiply this by y sub 2, e to the negative 3x. And y1 was e to the 3x, excuse me. So we still have the 3x over the 2. But this fraction is going to give us e to the 3x in the bottom. Minus 3 times x over 6 plus 1 over 36 over. That product is e to the negative 9x. In the bottom it'll be e to the 9x. Okay, that is where yp is. If I want to make it y general, I just add on the homogeneous solution, which was just c1 y1, that's y1, plus c2 y2, e to the negative 3x. If you didn't remember that's where it came from, you can always just copy it from here. And that's the solution to that problem. Let's try yet another one. Suppose you have y double prime minus 2y prime plus y, and this is equal to e to the x over 1 plus x squared. Since it's y double prime and not 3y double prime, we leave it like it is. And then we write down the corresponding homogeneous equation. And the auxiliary equation will follow. And two numbers that multiply out to 1 and add up to -2 are -1 and -1. So m minus 1 squared. Multiplicity is 2. That is, when m is 1, the multiplicity is 2. So it's not just y equals y particular equals c1 e to the 1x, but we need to take an answer just like that, except I change the constant. Instead of c1 e to the x, I just have c2 e to the x, and I multiply by x. If there were multiplicity of 3, if that were a cube up there, then I would take something just like this, except change a constant, c3x e to the x, and I multiply by x. I will get x squared. But that is our that is our homogeneous solution. c1 e to the x plus c2x e to the x. And that's y sub 1, and that's y sub 2. And our particular solution is going to be y is equal to u1 y1 plus u2 y2. So we need to find u1 and u2. Now, to do that, we're going to use determinants, and we're going to find y1 prime and y2 prime. But finding the derivative of y1 prime is pretty straightforward. Finding the derivative of y2 is a little less obvious. Use a product rule. So derivative first, which is 1 times e to the x, plus the first times the derivative of e to the x, which is e to the x. So we get 1 plus x e to the x. So we'll remember that. So now u sub 1, in the bottom, you're going to have e to the x, y1, and next to it, y sub 2. And underneath, the corresponding derivatives. And we're going to take the determinant. In the numerator, it's going to be pretty much the same, except for column 1. For column 1, because there's a 1 there, we're going to put 0 and then this. E to the x over 1 plus x squared. For column 2, it's just like what's underneath it. Okay, get rid of this cycle. So it's this product, which is 0, minus that product, which will be negative x e to the 2x, because e to the x times e to the x is e to the 2x, over 1 plus x squared. And in the bottom, you're going to have 1 plus x times e to the x times e to the x, which is 1 plus x times e to the 2x, minus that product, which is x times e to the 2x. Well, let's look at this bottom closely. You have 1 times e to the 2x, and then it says plus, and then it's x times e to the 2x, and then it says take away, that should be 2x. Then it says take away x e to the 2x. So the bottom is just e to the 2x. And the top is negative x e to the 2x over 1 plus x squared. Well, this is going to cancel, and you're just going to get negative x over 1 plus x squared. Negative x over 1 plus x squared. That is u1 prime, excuse me. Now let's find u sub 2 prime. U sub 2 prime. Well, we know the bottom determinant is e to the 2x, because it's the same as this determinant, and we just calculated it. For the numerator, we're going to get y1 and y1 prime, and then since it's u sub 2, we put 0 and g of x. E to the x over 1 plus x squared. So it's going to be that product, which is e to the 2x over 1 plus x squared minus 0. And we divide it by e to the 2x. So we get 1 over 1 plus x squared. There's an understood 1 here, and I agree that cancels out. So what survives is 1 over 1 plus x squared. Okay. This is u prime. Now, if u prime is 1 over 1 plus x squared, you should remember that the integral is the tan inverse of x. Okay, so u sub 2 is the tan inverse of x. Now, what is u sub 1? Well, we know that u prime is this. U prime is that. So then u1 will just be the integral of that. Just going to be the integral of that. And this minus sign I pull down in front. Now, if I call this u, if I let u equal 1 plus x squared, then du will be 2x dx. Well, in the top I have x dx. I'll put a 2. But then I have to bring a half in front. So right now, what we have is the following. We have u1 is negative a half of that integral. Well, the bottom, 1 plus x squared, I'm calling it u, and it turns out that the top, 2x dx, is du. So u1 is negative a half ln of u, but that happens to be u, 1 plus x squared. So I have u1, I have u2, I'm going to get rid of most of what I wrote, and I'm going to write down what yp is. Y particular is u1, which is negative a half times the ln of 1 plus x squared plus u sub 2. Oops, that's u sub 1 that I wrote. Now I have to multiply it by y1, e to the x, plus u sub 2, tan inverse of x times y2. That is a particular solution, minus some silly error. Okay. So the general solution is just addition. It's the particular solution, which I just wrote down, plus the homogeneous solution. C1 e to the x plus C2 x e to the x. There it is. Let's try another one. Once you start to catch on, this is very mechanical. Y double prime plus 5y prime plus 6y is 4x. So y double prime plus y prime plus 6y, we set it equal to 0. Homogeneous equation. And we have the 1 in front. Even up here we do. So this is going to give us m squared plus 5m plus 6, which is 0. Two numbers are multiply out to 6 and add up to 5, or 2 and 3. Positive 2 and positive 3. That's where it goes next to the m's. There's the m. There's the m. So m is negative 2 or m is negative 3. So homogeneous solution will be C1 e to the negative 2x plus C2e to the negative 3x, getting the negative 2 and negative 3 from there. Okay, so let's write that down. So you can have it for later. Of course, in your notes, you don't have to write it down on the side. You can leave it right here. It's just that I don't have much lower to write anymore. That is, I need to get rid of this. So we need to find U1 and U2. Well, first, we can find U sub 1 prime. Remember, that's going to be Y1, and that's going to be Y sub 2. Excuse me one moment, please. Here. Earlier on, I don't know what I was thinking. Initially, I said that this will be this as well as that separately will be solutions to the homogeneous equation. Then I said it wouldn't be. That was my error. Of course they will be. Of course they will be. So in the bottom, we're going to have e to the negative 2x along with its derivative. And underneath, I'm going to have e to the negative 3x, and underneath we put its derivative. And we take the determinant of that. In the top, since the subscript there is 1, for column 1, I put 0, 4x. In the second column, I put y2 and the derivative of y2. So that product, which is 0, minus that product, which is 4x e to the negative 3x. And in the bottom here, that product is negative 3 e to the negative 5x minus that product is negative 2 e to the negative 5x. It becomes plus 2 e to the negative 5x. So it turns out, since we're adding e to the negative 5x's, negative 3 plus 2 is negative 1. We're going to have negative 1 e to the 5x. Negative over negative is positive, and there's the 4x. Now, if the bases are the same, and they are right now, you should subtract the powers. This minus that is 2x. And the 4x, there's no reason why it wouldn't stay. So that is u sub 1 prime. Now, let us find out what u sub 2 prime equals. And just remember that the bottom is going to be negative e to the negative 5x. The only reason that you should calculate the bottom determinant a second time is if you want to make sure you got the same answer. Okay, we'll assume I'm right. It's a bad assumption, I know. I put y1, and underneath it, I put the derivative of y1. Since it's sub 2, I get the 0 and this function at the end, 4x. I calculate that derivative. That product is going to be 4x e to the negative 2x minus 0. And the bottom is negative e to the negative 5x. And understood positive over negative is negative 4x. This minus that is still 3x. Is 3x. So we have u1, we have u1 prime and u2 prime. u1 prime is 4x times e to the 2x, u1 prime, and I think u2 prime was 4x e to the 3x. Let's double check that. Oops, it's negative. Okay, so now we're going to calculate these derivatives, these integrals, excuse me. So, to integrate this, you get u1. To integrate the right side, I can pull the 4 out, and you get this. But this is a classic case for tic-tac-toe. You don't want to do integration by parts. I can take the derivative of x and eventually get to 0. X, derivative is 1, derivative is 0. And the integral of e to the 2x, that's also easily calculable. We have e to the 2x, the integral will be e to the 2x over 2, and then you're going to have e to the 2x over that 2 times that 2, it'll be over 4. So I'm ready to write down the answer, but let's not forget that 4. It's this product minus that product. But if you're slick, you realize that e to the 2x is always going to be there. It's going to be that product, which reduces to x over 2, minus that product, which is 1/4. Okay, so there's the e to the 2x. I'll distribute the 4. That will become 2x minus 1. That is u sub 1. Okay. Now, to find u sub 2, I just integrate this, and I'll bring the negative 4 out. Okay, so I need to integrate x e to the 3x. So X is friendly. X, the derivative of that, and then the derivative of that. And now we have e to the 3x. We integrate that. We get e to the 3x over 3. We integrate that. We get e to the 3x over 9. So we're going to get negative 4 times. I think it's clear that e to the 3x is always common. That product, after pulling out the e to the 3x, we get x over 3 minus that product, which is 1/9. And that's u sub 2. So we have u sub 1, we have u sub 2, and down here, I'm going to write down what y1 equals and what y2 equals. I think they were e to the negative 2x and e to the negative 3x. E to the negative 2x and e to the negative 3x. So we're done. Y particular is equal to u1, which is e to the 2x times 2x minus 1. u1 equal this times y1 is e to the negative 2x. Plus u2, which starts off with a minus. So it's minus 4 e to the 3x times x over 3 minus 1/9 times y sub 2, which is e to the negative 3x. Of course, this times that is 1 times 2x plus 1 is 2x minus 1. This times this is 0. Sorry, it's 1. It's e to the 0, which is 1, times negative 4 is negative 4 times x over 3 minus 1/9. That is y particular. If you want y general, it's going to be exactly what I wrote down on the line above. I'll even distribute the negative 4. Plus the homogeneous, which was c1y1 plus c2y2. And there is your answer. Let us try one more. Suppose you have y double prime minus 4y prime plus 4y, and this is equal to e to the 2x. So we find the homogeneous solution. That is, first we write down the corresponding homogeneous equation, which means we let g of x be 0. And then we write down the auxiliary equation. And I know half of that squared, there should be plus 4. Half of that squared is 4. So this is a perfect squared. It's n minus 2 all squared. Now, if you're squaring something and you're getting 0, that something must itself be 0. The n is 2. But the multiplicity is 2. That is, you don't just get c1e to the 2x. You have to get c1 e to the 2x times x. And we don't use c1. We use a different constant, c2. So that is the homogeneous solution. Or it's a family of them. What do I mean by family? For each values of c1 and c2, you get a different answer. Get a different y. Okay. So now we have to find u u1 prime and u2 prime. u1 prime, the bottom, so this is y1 and this is y2. It's going to be e to the 2x, the derivative, which is 2e to the 2x. And now we need to write down y sub 2, x e to the 2x and its derivative. Let's work that out on the side here. Now if you're slick, you'll realize you're going to be able to factor out an e to the 2x. Because when you take the derivative first, you don't take the derivative second. And that's going to give you e to the 2x. And when you do, and then you keep the first, and you take the derivative second, which is going to be 2 e to the 2x. So the e to the 2x is going to factor out. When you take the derivative first term, first factor, you get 1 times the second, plus the first times the derivative second, which will be 2 e to the 2x. That is the derivative. 1 plus 2x times e to the 2x. And since we're solving for u1, 1 being the key term that I'm saying, it's going to be it's going to be 0 e to the 2x. 0 e to the 2x. And column 2 from below doesn't change. It's x e to the 2x, 1 plus 2x times e to the 2x. It's going to be that product, which is 0, minus that product, which would be x e to the 4x. In the bottom, you're going to multiply this. You're going to get 1 plus 2x e to the 4x minus 2x e to the 4x. You're going to have 1 times e to the 4x, which will be e to the 4x. And then you're going to have 2x e to the 4x. And that's what you're going to take away. That is, the bottom is just e to the 4x. It's just e to the 4x. And this cancels, and you get negative x. So u1 will be negative x squared over 2. I integrate this, I get u sub 1. I integrate that, I get negative x squared over 2. Okay, now I play the same game for u2 prime. U sub 2 prime. The bottom, I know, is e to the 4x. Since that's u sub 2, in the first column I put y1, and in the derivative of y1. But for 2, for the second column, I put 0 and g of x. G of x being e to the 2x. And that product is e to the 4x minus 0. It's just e to the 4x. It gets divided by e to the 4x, which is 1. That's sweet. The derivative of u gives me 1, then u must be x. Okay. So now I know that y particular is u sub 1 times y sub 1 plus u sub 2 times y sub 2. And become x squared e to the 2x. Now, let's look at the negative x squared over 2 as negative a half x squared. And this is 1x squared e to the 2x. I'm adding the same things. First I have negative a half, and then I add 1. Negative a half plus 1 which is the same as 1 minus a half is a half. I have a half x squared e to the 2x. That is y sub p. If you just want y general, if you now want to go and get y general, just add on the homogeneous. C1 e to the 2x plus C2x e to the 2x. And notice that these three are not the same. If they were, for example, if that over here was x squared, I would say that we don't need that. But we most certainly do. We most certainly do. It's negative a half x squared e to the 2x, and there's no 2 up here. So to go from the particular solution actually, nothing's wrong, but I just meant to add it on, not to say equal. Plus C1 e to the 2x plus C2x e to the 2x. If you have a particular solution, just add on the homogeneous solution and you'll have the general. And if you're given some initial values, like 2 initial values, you can solve for C1 and C2. This completes the section on parameters, variation of parameters.